Hi, I'm Dongwoo and this is my presentation for the FINAE project, and this project aims to model contact network and spread of COVID-19 in Singapore. In order to create a viral transmission model, there are two main parts to such simulation. First is the population modeling. There has been many studies to create an accurate viral transmission, but many of them do not consider the population structure of Singapore. Therefore, the results of such reports are not guaranteed to apply equivalently in context of Singapore. Second part is the population modeling. Many researchers use the SEIR model, which may not be the most realistic model. The purpose of this project is to generate a realistic simulation model of virus spread in Singapore to help Singapore deal with any future viruses, epidemics, or pandemics. This purpose is achieved by doing three things. 1. Creating a contact network that replicates the population structure of Singapore. 2. Creating a simulation model that can replicate real data in Singapore. 3. Creating a web simulator to easily simulate and visualize the results of the simulation. First is the population modeling. The aim is to create a network that entails these population characteristics. Those are the number of population in Singapore, the age distribution, and the household characteristics. The best contact network that was generated was the combination of multiple networks. First was the contact network with household members. Second was to create the frequent daily contact network for each age group using the fast generator. The household interaction is important because it is a form of community. It is especially important in viral transmission because the interactions with household members exist regardless of how strict the government restrictions are. The following pseudocode is used to create a network of households. Another set of contact networks is created to describe daily interactions. Daily interactions usually stay within the age group in age group specific community. For example, working population interact with other working population in a community called company, and juvenile population interact with another juvenile population in a community of school. Therefore, contact network is created for each group using the forest generator with the below pseudocode. This is the resultant degree distribution of the network generated while capturing household and age properties of Singapore. They also capture real-world network properties. The simulation model is built to make use of the generated network. The SEI3R model is used as the main transmission model, where the viral transmission is depicted as the diagram. While using an open source framework to do viral transmission, it is modified to fit the need of this project. First is to collect the number of positive cases per day. Second is to immediately isolate individuals who is tested positive for 14 days. And third is to allow flexibility in imposing government interventions. Multiple government interventions used by the Singaporean government are implemented as functions. The interventions are social distancing, quarantine, trace together, social gathering limit, and circuit breaker. In order to reduce the computational time for the simulator, dynamic scaling is used, which is based on an idea that when the number of non-susceptible population is small, the size of population does not influence how the virus spreads. This significantly reduces the computational time at a cost of little accuracy. In order to check the correctness of the simulator is used to simulate Singapore's virus spread from February to May in 2020. This phase of dates is chosen because significant government interventions are first introduced during this time. Firstly, trace together is introduced. Secondly, social gathering restriction is introduced. And finally, circuit breaker is introduced. All of these are replicated in the simulator. The result of the simulator is shown as the number of new positive cases per day, and the figure shows the median of 100 iterations of the simulation. As visible, the result of the simulation and the actual historical data in Singapore is very similar. This presentation is concluded with the video of the web application. Thank you.